Hi, today we will start with Cuda programming, and to get started it's important to understand difference between CPU and GPU and few important terminologies around it. We are starting with something called FLOPS, which is unit of instructions can be performed by your CPU in a second, right? So it can be measured in FLOPS, and if it is a big number, that means we can measure it in gigaflop, that means 10 to the power 9, that's gigaflop, and 10 to the power 12, it's teraflop, right? So I have written a small code to demonstrate how exactly number of operations will be performed by our CPU, how we can measure it, and then how we actually calculate teraflops, gigaflops, or number of flops, right? So you can easily understand these are just unit of flops. If number is very big, we can actually calculate it in gigaflops and teraflops. So I have created this variable here. So we are actually performing here billion operations. We wanted to perform billion operations in this loop, and I have defined some of the floating point numbers here, A and B, right? And we will actually store that calculation in C, right? To get started, we have started our clock to measure the time it took to complete these billion operations. And then once these operations will be finished, we will capture it into ending time, right? How much time right now? So we can actually take the difference between the start and end, and then understand exactly how much duration has elapsed, right? So we will print elapsed duration here, and then we'll find out how many iterations will be performed in 1 second by calculating the number of instructions and how much time it took to perform those instructions, right? So number of flops will be iterations divided by elapsed time. If it is a very big number, that means 10 to the power 12, then we will call it teraflop and the measuring unit will be teraflop. If it is 10 to the power 9, we will call it in gigaflop. Or if it is, let's say, some smaller number which is even smaller than 10 to the power 9, we can easily call it flops. Right now, we are in debug mode right now, and let me actually go ahead and run this code. You can see the output here. So it took around 1.31 seconds to complete 1 billion operations, and it says it is, or capacity of my CPU is 7.6 flops, right? 7.6 into the power 8 flops, right? It's generally video recording is going on, otherwise it easily goes to some gigaflops, 1.2 gigaflops or something. But important thing here to understand is in 1 second these many instructions will be executed, 7.6 instructions, right? Now let me show you something magical here, right? I am making this into release build, and if I run this application one more time, it says now this number has significantly reduced, 10 to the power minus 7, right? And it actually performs 10,000 teraflop operations in 1 second. Now again, this particular recording is started, that's why it's this small number. Otherwise, many a times I have observed, since the elapsed time is 0, that means it's so small that it cannot assume it start assuming it is 0. It's below range of floating point number, so it might be like 0.00000 some seconds, right? And then this teraflops comes out to be infinite, or infinite flops will come here, right? Let me try one more time in release mode and see exactly. Yeah, so you can see here elapsed time is 0, and it is actually having infinite teraflops. That's not true actually, but what is happening here is this variable C, it is being run in the loop, and that's why this is optimized by the compiler, right? And compiler do this kind of optimization quite often. So if I want to stop that optimization, uh, let me actually use this variable qualifier called volatile, right? Yeah. And if I run it again, then that optimization has stopped, and you can see elapsed time is 0.23. Again, it's way smaller than what it took for debug mode, but it's a number which we can really imagine and calculate, right? And it's in gigaflops, it's 4.3 gigaflops is the number, right? So volatile is a keyword which actually stops optimization of your variable. So let's say if your variable in RAM, it will actually take into cache memory, because it compiler understands that it is being used in the loop, right? So that's the magic of this volatile variable, right? Hope you understand this. In next video, we'll go dig further into this, and yeah, that's it.